Hello everyone, a very good morning. I'm Leona from Wizlogix, the host for today's webinar. So Wizlogix started bringing in trainers from overseas in year 2007 to run courses that can enhance knowledge and skills of electronic industry practitioners. In partnership with Black Fox and SHRDC, we have become the IPC Authorized Training Center in Singapore to offer a series of IPC certification programs. Over the years, we have worked with many experts coming from different countries. That includes also coming from Singapore, our local experts. So allow me to welcome one of our local master trainers, Mr. Wayne Leong, who is certified to train CIT, CSE, and CIS in IPC standards 600, 610, and 620. He's going to share with us on the topic, discover the acceptance criteria for bare printed circuit boards in this morning session. So without further ado, let me pass the time to Wayne to start with his sharing today with you. Wayne, please.
Okay, very good morning to everybody. It's really a pleasure that all of you will join in for this webinar. Okay, so actually now we're going to talk about it's more of the acceptability of criteria for this printed circuit board. So this actually all the details of that will give you a very rough details of what we are going to have. Right? Because if I'm going to give you more details, then it will take up quite a lot of time. So important actually is that why actually we certified to give an understanding, and then it helps you to save money. So because actually, as you all know, that the PCB actually in general is the most important component into the board assemblies. So example is that if a bad PCB, right, no matter how good your component is and how expensive your components, once mounted, the part will not able to work. And once that happens, then your whole product will become a failure. And important actually is that if you have all these failure products coming in, right, so that you need to have a lot of recall costs, and also reputation also will be affected. So here actually is that in your company, everybody will also clear is that if we do not give your managers actually a good knowledge of how to make proper decisions, right? Examples that when the incoming boards are having issues and all that, you actually must need how to elaborate what are the issues that you're going to face. And all these details are given to your manager will be able to give a good decision of whether to proceed ahead with the production or to stop the production and then return the boards to the supplier. Okay. So that's why all this actually will help you to save costs in that. Because once you run the production, all this actually will be wasted. Especially for OEMs also, right? Whatever it comes to it is that all expensive items, components that comes in, right? The cost of PCB might cost you about $100+. But after you mounted all the components inside, it may cost you thousands and even though some millions of dollars to go to that. So that's why coming to the nature of it is that if you can really detect a defective PCB much earlier, we will not able be wasting time on actually assembling the parts and wasting a lot of money, because actually every manufacturing process actually is a costing, right? And worst of all is that if you got failures during the customer end side, right, when they're using the product, they also have a very bad image on your product quality, and ending up you need to have a product returns and recall all the set, right? So important actually is that you need to train your people so that they have a good knowledge of the PCB requirements, and then chances of having a bad PCB into the production line will be very, very minimized. So under here actually is that for PCB itself, same as other product also, it also comes with 3 different classes of application. So mainly actually is that who are the one to be responsible for identifying the class of product, it actually will be the customer. Because customer is the one to pay for the costs and all those, right? So in a way is that whatever type of product they want, they also will be the one to make a decision, right? And then they actually classify into 3 classes. Class 1 actually is the general electronic products, where the main application is just function. So whatever things once they assemble and you activate it, it start to function, that fulfill class 1 requirement. Then next actually come to the dedicated the service electronic products, which is under class 2, which actually this one comes to it is that it gives you the reliability and some lasting of the product applications. So Later, actually, I'll give more details of what are class 1 and class 2, and also the last one is really class 3, which is a high performance under harsh environment electronic products. Where this one actually comes to is that it cannot fail. Okay, so now I go into details of it. Is that example for class 1? These are the general electronic products that we are talking about. Like examples of game consoles, like speaker sets, then video applications, some phone equipment and phones and all those that. And actually, even though some lightings also, they are actually under class 1. But what it comes in is that these classes of application is that you purchase it, you pay a low cost for that. But you will never expect it to last you forever. So whatever comes to it, like they actually what they do hope is that this one can last as much as it can. But basing on the nature of the cost itself, right, it will not give you actually very, very lasting. Right? It might actually last from months to maybe year. Okay. Next come to actually is a class 2 product. So class 2 products actually are more for dedicated service electronic products, where this one example is your laptops, photocopiers, and then some of the life science equipment and some of the very a bit more sophisticated electronic equipment. So what it comes in is that it definitely will cost more money, and then comes to the nature of it that it definitely will last for years, right? But in a way is that it will not last forever. So what comes to the nature of application of it is that, right, we are expected to have uninterrupted services, but if it's failure, it's not critical. So in a way, actually, that not critical means it will not affect any injuries or life in that case. Okay. Lastly, comes to actually be the class 3 product, where these are high performance and harsh environment. So examples of this one is like aerospace, right, in aeroplanes, right, in actually life support systems, and those that. Right, even though for cars also, cars it comes in actually is a brake system. Because actually for this one is that if it fail, what happens? Just like a plane, when you're sitting inside the plane, right? Once it fail, the plane will not be able to transform into a transformer, like what you see in the movie show, right, and land on the floor, right? You crash all the way down, and all the people on board definitely will be suffer, right? And they easily will lose all their life and all the time. So these are very critical, and definitely we will not want it to fail. Right, example for life support system also, right? If actually the patient is using it as a life support, if it fail, what happens? The patient will not be able to continue to survive, and definitely will cause to death. Okay, so here actually that we do have actually a poll question, right? Where this one comes into the nature of it is that we actually have a few products over here. It's more or less actually is that under this few product, A is about nuclear weapon, B is about the zapper, C is an anti-lock brakes, and then D is a AED. So all this comes in is actually that which of this product is only classified under class 1. So we look into it is that see which one is crucial, right? And you can see that whether the critically of it is that which is more critical, right? And important actually when you look into the nature of this one is that what actually costs life, right? And then when it fail, life actually will be affected. So we'll see into the nature of this one actually is that, right, under class 1, this is the most lenient of it all, that actually the main thing actually is about function, right? So what is the thing that it must function, and then it will not cause any unnecessary unhappiness. Okay, so now actually we end the polling, and then you can see that under the poll there, right, majority of it is actually is answered correctly, which actually the class 1 product is butt zapper. Although it costs life, but this part is the one that we don't want it to survive, right? Because actually butt zapper, if it allow it to survive, it actually will attack us and cause a problem to us. So butt zapper actually is the one that is fit into the class 1 application. So example that if it fail, only thing is that we cannot kill the bug, that's all, right? But nuclear weapons, all this one, you can see that if it fail, right, instead of bombing into your enemies, it might land in your allies, or even the worst of it, you land on your own self, right? So next actually comes with the anti-lock brakes, where actually apply in cars, where actually 8% of it reply on that, because cars actually are crucial. So if a car brake is spoiled, what happens? Right, the car will need to hit something to make a stop. Right? If it didn't hit anything, it will actually continue to move. And on the road, as you all know, that there's no way for the car to stop without having to wait. Right. Next actually is the AED, where actually you need it to save people. Actually, it's a life support system. Right. Anybody actually got a heart failure or whatever is that they fainted, they need that actually to reactivate the part functions. So definitely these one are under class 3 also. Okay, so next actually we'll go on to the next item, right? Where actually comes to the nature of it. You can see that what are the different criteria? First, they are talking about PCB and all this type. So when it comes to inspection of a PCB, what are the things that we are looking for before we can accept a good quality PCB? Okay, here actually under the PCB requirements, right, and inspection all this type, they actually classify into two major categories, right? First one actually is that externally observable, where these actually are the imperfections or the so-called in simple defects, which actually can be seen on the exterior surface of the board. So all this actually thing comes in is that when at times I look at the board, you can see this feature without doing any cutting or any breaking of the board itself. So these are defects that will be seen externally. Next come to it is actually is that there will be the internally observable, where all these internally observable defects, all this one, you cannot see from the external of it. You need to cut open the board, right? And then actually to section it and then to see what is inside there. So normally these one are on non-reversible type of things. Once you cut it, it definitely will be a destructive test and the board will be damaged. Okay, so actually these are the two things that on this topic they're going to be talking about. So externally observable, right? Some will say that, oh, what are things that we can see externally, right? Example of surface imperfections, right? Those are actually burrs, nicks, and voids, as you can see on the surface of it. So all this actually will be talked about is how they're going to distinguish and to judge what are acceptable, what are defects. And then next actually come to the subsurface imperfections, which are the defects that's underneath the surface of it. So these are mainly those foreign inclusions where we actually they call it the alien material that are being stuck onto the board, and then they after that cover with solder mask and all those type of coating. So these actually are subsurface type, right? And then some of the delamination, right? Some of the internal voids that you can see. Next, actually, they will talk into about the conductive pattern. So all these conductive patterns are the traces and the VRs and all those type. So whatever is that, how much reductions of the conductive width is acceptable, and how much of the thickness actually they've been being affected on that. So next, actually, you talk also about the whole characteristics for this training, and more or less into the diameter, right? And the misregistration means actually all those holes are drilled or laser, and actually if they drill incorrectly, it actually become a misregistration. So also look into actually about some of the plating defects that where actually be caused onto the diameter of the hole. Also, we talk about the marking anomalies, right? Under this training, you talk about the location of the marking, right? Although you say it's something simple, but actually you represent the identification of the product itself, right? Next, also on the surface mask, surface coating, right? Where all this actually, what are the things that happen that when they didn't apply as a solder mask properly onto the PCB, right? So they also might have caused a misregistration, bristles, right? Delamination, and then some of the solder mask adhesion. Okay. Next, actually, the example of the one actually is about delamination, right? Delamination, as you know, that nobody wants it to happen, right? In the ways that how it happens that this one they cause the board to separate internally, and this one can be seen externally, right? In sales and in shopping, a lot of people like, oh, this product, like buy one free one or buy two free two. Everybody rush for it. Or when running of a PCB, right? In the assembly, nobody will want that. I run one board inside, but I come out got two boards. And worst of it is that two boards cannot be used. Okay. So this actually is another whole question where we want to look into, right? In a way, actually, is that this during machining of the board, things actually happen, and then they might have some burrs that happen to it. So you look at the picture shown, and then they see that which one actually these are all non-metallic burr, right? How is the condition of it? Whether both are acceptable or only one is acceptable. So you all actually can access to it and then to re-evaluate like, what are the things that we are looking into, right? What are the acceptable items that we look for, right? Whatever it comes in, what happened to it if it got burst and all these fibers are being loose and all appear up. So important actually is that what happened is that what does this burr will cause to do our assembly, right? Important actually is that if they got a lot of burrs that happen to it, what happened? It actually will start to attract a lot of moisture, and then also will affect on the main board assembly, right? When you're going to assemble onto the casing or the chassis, you will not be able to mount into that. Okay, so we end the pooling here, right? Looking into the result, actually 96% of it actually is that answer correctly, which is figure A, right? Figure A is the one that we do allow a little bit of burr to be accepted, right? But for figure B, this one is too bushy already, right? In a way is that for men, they got a lot of beard, it looks very macho, but on the board, when they got so much fiber happen to it, nobody will like it. Because actually what happened, you attract a lot of moisture, ending up actually they might cause the board to delay. Okay. So next actually we will proceed on to the next one, where we also have another poll question on this one. In the way actually is that you're looking at these three pictures. These are so-called, these defects are so-called Halloween, right? Halloween actually are one of the one that we'll talk about during the training, that how does this going to happen and what does it cause onto the nature of it. But under this condition is that what are the things that are acceptable. So you look into picture figure A, figure B, and figure C. So your well will look into that to assess that which is acceptable condition, which one is either any of it is not acceptable. Because this one actually is a mainly cause of it is that is during the machining, right? When they cut the board at the time, the machining tool is not sharp. So ending up actually is that the machining tool, instead of cutting the board to give you a good edge, they actually will start to tear the material away and causing the board to fail. Now basing on the result, 27 of this 96% of it actually is that the answer is only figure A is acceptable, 4% on figure B, but 0% on figure C. So in a way actually is that the correct answer is actually is that figure A and figure B is acceptable, right? But not figure C. Because figure C, the hallowing is very severe. And then there's not enough material to hold the board in place. Okay, so this actually will be actually one of the topic we'll talk about also during the training. So next actually we're going to the next topic. We actually is another poll question also. So under this one, you can see that there actually are some void condition. Void condition that means actually that it could be an air trap, it could be actually a vacant inside there. So under this condition, right, you can look at both pictures and then assess which is a acceptable void condition or both actually are not acceptable. So basing on the poll question, you will evaluate which one are the things that is being acceptable to you. Right. Mainly because actually under the training, we also will talk about all this, and then actually we'll give you more details on what are the things that they'll be looking into. Okay. So of this one, actually now we end the pooling. Very good. A lot of your all 100% actually answer is figure A. Correct. Figure A actually is the one that's been acceptable, because actually looking into the nature of that is that, right? Figure A actually you can see a very tiny small void there, and this one actually it will not affect any dielectric between the two isolation, right? The two pressure through holes, right? They are being properly isolated, and this tiny void down here actually still will be acceptable. Figure B actually is that because the void, right, in actual fact is 0.89 mm. So in a way actually is that this void actually is a little bit big in size, and then important actually is that if the void fall between the two pressure through hole, right, ending up actually that the isolation dielectric between the two will not be working properly, and then ending up actually they actually create actually a short over there. Okay, so next actually we go to the next one, right? So this actually is talking about internally observable type of defects that you will see. So mainly when it comes in, you need to cut the board, right, to open up and then to see what is inside. And seeing in this one actually is not easy just by naked eye. Normally this one will be use of a high magnification to actually to check into it, what are the things being observed over here. So under this internally observable, actually we need to talk about it's more of the smear removal. So in a way is that after the board they have been drilled, right? They need to remove all the burrs and all those stuff inside there. So in general, we call it a smear remover. So removal of the resins and debris, right, in a way actually is that they need to clear it away. If they're not properly clear, they actually will cause nodules in the wall, and then the places through hole, the diameter will become smaller, and ending up actually affect not able to do a assembly. So combination of actually die trait removal actually talk also about HVAC. So where actually is that if they want to link the internal to the external components or whatever is that, they need to actually go for some plating process. And then during plating, it talk about the HVAC, that means the expose of the internal conductor to be exposed to the hole there, then they can start plating. Right? If the internal conductor is not being exposed to the outer surface, right, there won't be any copper plated onto that. That's why on to the HVAC of the internal conductor, how much they need to be exposed, and then in the ways that they can actually add copper to it. And also about those resins, which actually is the laminate actually that use it to do the isolation. So if the smear remover, that means the resins are not cleaned properly, they also will create some of the problems. So, and then wicking allowance more or less is that during drilling they might actually tear the wall away and then cause the copper to be plated onto those cracks into the hole there, and then ending up actually they might affect internal short, and then they onto it. So we also talk about actually those coping plating evaluations, right? When they assess about the plating thickness. So how much thickness is required for class 1, class 2, and class 3. So in general, actually the minimum requirement for class 3 actually is 25 microns. Class 1 and class 2, minimum requirements is going to be 20 microns. So all these actually are the requirements that when during assessment, we actually can evaluate whether the holes are properly plated, right, with the copper plating wall thickness, meet the requirement, and then give the performance. Okay. Next, actually, you talk about internal observable is that if actually you can see that if the dielectric material with the laminate are not properly removed, right, you actually will stuck onto the internal conductor. You can see that this whitish thing over here, this actually is the internal conductor, right, and the black color one actually is the resin. So example is that if the resin actually wasn't able to remove away, right, it actually will become a isolation internally. And this one actually will cause the plating to fail onto that. Because actually any resin that stuck down there, it become an insulative material. The copper will not be able to add onto the internal conductor and create a connection. So that's why all this actually is crucial. And during actually in general on the board we cannot see, but we only can see it actually is after we section the part. And this one will be the job of the PCB manufacturer. They actually will cut the board, mold it into a coupon, and in the coupon actually is that we can review this all these sort of defects and issues under high magnification, right, and able to measure how much actually is the plating requirement. Okay. Next, actually, I'll talk about the HVAC also, right? Internally observable actually HVAC, that means actually that how much copper has been extended out. And in a way, when plating, they also need to have the interaction between the internal copper and the added copper to it. So how much you're going to add on, right? The more the surfaces, definitely the better it will be. But in a way, doesn't mean is that you have to maximum everything, then it's good. Because this is something that's not easy to control. And we also do not want the internal copper to protrude out too much. Because if the copper is being protrude out too much, as you can see that over here, right? These are the one that comes in, this is the internal copper, as I show my arrow here, right? If they protrude too much, any copper added to it, the thickness actually will proportionally be plated over the whole surface. Ending up this one to create actually a nodule over here and cause the diameter of the plated hole to be smaller. Next, actually talking also on the wicking measurement, right? We also need to look into how much actually wicking are allowable. Because actually at times when the drill is not sharp, so instead of cutting the hole vertically down, there has been some laminate, as you can see under the tool here, right? Item 2 down here, they're having cracks on the laminate. And during plating, all these cracks will be filled with copper. So the concern actually is that there are internal layers actually that happen that is not shown on this one. But if the wicking is too much, it actually will reduce the dielectric between the copper and the laminate down here. So the laminate actually must isolate so that the copper internally will not short to the printed through hole. Okay, so in a way, actually, all this type of thing that comes in. Why companies actually send employees for training and all stuff? Important, as you can see, that whatever comes to training, right? If you educate your staff, like your incoming, your inspectors to actually have a good training and a good understanding, it actually helps company to save a lot of money. Because actually, whatever it comes to it is that knowing how to inspect a board is not that easy. There are a lot of criteria, a lot of items being involved into it, and how we're going to do about it to actually create a very good understanding of a good board and then a bad board. Lots of cases actually is that the inspectors do not know how to inspect a board properly and allow defective boards to go into production. And when production running the time, nobody will know, right? But when the result comes in is that after every assembly has been done, right, the board actually failed the functional test. So all these are the things actually that is actually can be prevented upfront if they got proper training over there. That's why actually companies willing to send employees for training. In a way is that training actually they do have some costing into it, but actually you save the company more cost onto that. Important actually that you got a good board go inside, right? Definitely you come in with a good product. If a bad board is in the production area, you can never expect it to be a good product. Worst of all is that if you have very expensive components mounted to it, and some components can be as much as 100 times, and even though a few hundred times more expensive than the PCB. Okay, so that's why company willing to send employees for training, because actually that they can look into the advantage of all this sort of training. They actually will gear them up, they have more knowledge and a better understanding. So in a way, actually it helps the company to have more saving. Okay. So here actually that I end the share of this webinar, and then actually I pass it back to you, Leona.
Thank you again, Wayne, for your enlightening sharing today. Do consider joining our full IPC 600 CIT, CSC, and CIS courses. Look up the course brochure and contact us to reserve your seat. Thank you all for watching. Have a nice day. Goodbye.